Okay, we're in part 2 of our video on graphing polynomial functions. So for example 4, did you see from your calculator that I can use -2, 4, and 6 with synthetic division? So pick whichever one you want to start with. I'll just start with -2. And I have -1, 8, -4, and -48. So bring down the -1, multiply, you get 2, 10, -20, -24, 48, 0. If you've forgotten how to do synthetic division, pause the video and ask a neighbor, or look back at your notes from last week. So factored form, I have x plus 2. That's going to be -x squared plus 10x minus 24. Now, for this trinomial, I'm going to take out a negative. So I have -x plus 2. Then this will become positive x squared minus 10x plus 24. And I know I need to factor that further, which I can do with the AC method. So I have -x plus 2. What two numbers can you multiply to get 24 and add to get -10? That's going to be -6 and -4. And since I factored out that negative, I could do the shortcut there. So my solutions are -2 single, 6 single, and 4 single. From the beginning, it was odd degree, negative leading coefficient. So think about a line that's falling. And then plot your points. I have a solution at -2, 4, 6. My end behavior is going up on the left, down on the right. And these are all single roots, so it's going to cut straight through. If you watched me walk through that one, why don't you try to pause the video and do number 5 on your own, just to make sure you're able to find your solutions, and then graph. Okay, so here I'm going to take out an x squared, and I have x to the 4th minus 21x to the 3rd plus 80. So I actually took out the wrong thing here, sorry. Your GCF is x to the 3rd. So let's take out an x to the 3rd and see if this is a little bit easier. So that will be x to the 4th minus 21x squared plus 80. So I would try to do the AC method here because I know I can do the shortcut. I know that -16 times -5 is 80 and add up to -21. So that's going to be x squared minus 5, x squared minus 16. So this is going to be x to the 3rd, x squared minus 5, x plus 4, x minus 4. Can you see that your solutions are 0, triple, plus or minus the square root of 5, -4, positive 4. To make graphing easier, you need to know what the square root of 5 is. So put that in your calculator and you will get 2.236. So let's just say 2.2 for graphing purposes. Draw your coordinate plane. So I have solutions at -4, 0, 4, and then -2.2, positive 2.2. And we didn't talk about end behavior, but it was odd degree, positive leading coefficient. So it's going to be down on the left, up on the right. -4 is a single root, so is negative radical 5. 0 is a triple root, so it needs to slide through. Positive radical 5 is a single root, and positive 4 is a single root. You can check your number of turns here. Remember, I should have 6 turns, but this is going to be a little bit different. So we have 1, 2, 3, 4, and then your triple root counts as 3 turns. Sorry, excuse me, 2 turns, since it's a slide. So 1, 2, 3, 4, 5, 6 turns there. Okay, now we're going to go backwards. We're going to write the equation of k of x. Since both ends are up, I know that my leading coefficient is positive. My degree will be even. So let's look at our solutions. We have -6 is a double solution. -5 is a single. -3 is a single, 0 is a double, 2 is a triple, 3 is a single, 5 is a double. So I'm going to say k of x equals, you always put your 0 first, so this will be x squared, and then I'm going to do x plus 6 squared, x plus 5, x plus 3. Now this should keep going this way, but I'm going to come down since I ran out of room. So I have those taken care of. I need x minus 2, it's a triple, so to the third, and x minus 5 to the second. The fundamental theorem of algebra we've already been talking about a little bit. This just says if you have a 5th degree polynomial, you'll have 5 roots. If you have a 4th degree polynomial, you'll have 4 roots, and so on. So now let's change gears a little bit. I want you guys to find the factor that yields the 2 messy roots. So here, in order to get plus or minus 2i, I had to take the square root. So I'm going to do the opposite and square both sides. So I'll have x squared equals 4i squared. Do you guys remember that I squared is -1? So I have x squared equals -4. If I add 4, x squared plus 4 is the factor that gives me those roots. So let's jump over here to number 3. Square both sides, and you get x squared equals 25 times 2 times I squared. So x squared equals 50i squared. Remember that I squared is -1, so x squared equals -50. So x squared plus 50 is the factor that yields that solution. Now I want you to pause the video and do the next 2 on your own, and then press play when you're ready to check. Okay, so these roots, we're going to do the same thing, except if you'll notice, these are binomials and not monomials. So I want to square both sides, but I need to have the plus or minus by itself before I square both sides. So for this, the first thing I'm going to do is subtract 1. So x minus 1 equals plus or minus 6i. Then I can square both sides. You'll square x minus 1 with the FOIL method. So if you need to go off to the side and do the FOIL method, you can. Or if you know that's going to be x squared minus 2x plus 1, that'll save you some time. And that's going to give me 36i squared. Remember that I squared is -1. So x squared minus 2x plus 1 equals -36. So x squared minus 2x, if I add 36, that's going to give me plus 37 equals 0. So this is the factor that yields this solution. So pause the video, try number 6 on your own, and then hit play to check your answer. If you have any questions, rewind the video or ask a friend. Okay, it looks like this is going to be the end of video 2. Hopefully we can fit the rest of this lesson into the 3rd video. So go ahead and hit stop here and move on to the 3rd video.